to pick up where we left off yesterday, which is on the back side there, right? The front side, they gave us these fun equations, and we had to graph all the little pieces, right? Now we're reversing it. They're giving us these graphs. We have to write the equations. Okay, that is the main part of our goal today. If you think about what it looked like on the front side, if you flip back and look at it on the front side, when they write these piecewise functions, you usually see it as f of x equals, and then they'll put that little open brace. Okay, and that's just how they connect them together. So that's your official notation. From this, how many pieces am I going to have to write for this one? There's 3 pieces here, aren't they? Now, just like yesterday, good news, all these pieces are just pieces of straight lines, yes? So that means every single equation today that we're writing is essentially a y equals mx plus b. Okay, it's just figuring out the slope and intercept of all of these and then figuring out their x values. So, I don't know that Savas cares which order you do these in. Okay, because officially you can write these 3 pieces in any order. I tend to go left to right, and I think that's what you'll see, like if you get an answer from Savas, what they'll do. I don't think it officially matters here. So if we think left to right, I'm going to start with this piece here. Okay, so I'm going to make it my green piece so I can, just so you know which one I'm talking about there. Okay. I need to know a slope and a y-intercept for that piece. Can you tell me a slope, Savannah?
The slope would just be x.
Okay, so what's the number in front of x then?
1. 1 over 1.
Almost.
Negative.
Negative 1. Okay. So how do we find slope? Quick review here. What's the phrase you should be thinking today? Rise over run. When we rise over run, if we rise over run, we can do this either way. We can rise by going down 1 and then right 1. If you do down 1, that's negative 1, right 1 is positive 1. Or you can do rise over run by going up 1 and then left 1, which is positive 1 over negative 1, right? So slope is negative 1. Now, when we write that, that's the number that goes in front of x, right? Do you have to write negative 1x?
No, you can just write 1x. You can write negative x.
You can just write negative x. Now, will Savas count you off if you put negative 1x? Maybe. Okay, so in all honesty, if I'm doing this, I'm just probably going to write negative x. And then, plus, I need to know y-intercept. Well, as of right now, it's not crossing the y-axis, is it? But you need to extend it. Figure out if we kept going, where would it cross the x-axis? Okay? I'm hearing some zeros. And when I say extend it, just think about continuing your slope. What would we do to continue the slope? We could keep going down 1, right 1. Down 1, oh, right 1. Where did I just go through?
0.
A 0. So, an option, you can write plus 0 here, couldn't you? Or, just leave it as y equals negative x. Now, according to a first hour student, they said that you can put plus 0 and Savas did not count them wrong. I can't guarantee that, but that's what was said this morning. Okay? Again, if this is me, I'm probably just going to say y equals negative x. Now, we're not done with that green piece, though, because that line doesn't go clear across, does it? So we've got to give our domain, just like yesterday. Okay? Your domain's going to look like yesterday in that they're going to want the inequality. So I'm always going to have x in the middle. And I will tell you that on either side, it's always going to be less than signs. Okay? Because what we're doing is we're going to put the smaller number on the left, less than x, less than, and bigger number on the right. So as long as you're putting smaller number on the left, bigger number on the right, those will both be less than signs. What are those x values? How far left does that green line go?
-3.
Goes to -3 right here, doesn't it? So -3 less than x less than, how far right does that line go?
-2.
Goes to -2. And,
There's a line under the first one.
okay, you have to ask yourself, were either of these equal to's? And that first one at -3 was a filled in circle. So it's -3 less than or equal to x less than -2. And you're 1/3 of the way done with this problem. Okay? Do you see how I'm doing this? Okay, let's pick a different piece and go for it. I'm going to do my middle piece now. What do you know about that? We talked about these yesterday a little bit, didn't we? Do you remember how to write an equation for those when they are that horizontal line? Logan?
This one would be y equals 1.
And why is it y equals 1?
Is it a straight line on 1?
Yeah, it goes through 1 on the y-axis, yes? So you can just say y equals 1. Now, what would be the slope of this line? It's 0, right? So you could say 0x plus 1. Again, I don't guarantee Savas would go for that, though. So I would just say 1, because it's a straight line that goes through 1. On what domain? How far left does my blue line go? -2. Less than x. Less than, how far right does it go?
1.
To the x value of 1. And then, I didn't fill them in at the time, but are any of them equal to? The first one was a filled in circle, so we're going to have an equal to. Part 3. Let me pick a different color. This is where I struggle with what color will show up. We're going to try pink. It's not great, but it'll work. At least I think it works. Okay, so now we've got that pink line. I would say start off with slope, especially since it doesn't even touch the y-axis right now. What's my slope? And I'm going to make someone other than Savannah and Logan answer this one. I'm denying them. Jack?
4x.
4x? Because what's my rise? We're going to 1, 2, 3, 4 over 1, yes? So slope is 4. We're going to have 4x plus, how do we figure out where it crosses? Yeah. If this was up 4 over 1, I can now reverse it and go down 4, left 1. And that puts me where? -5. So 4x minus 5. Okay. Are you filling in your domain values? How far left, what x value left does my pink line go to?
1.
1 less than x less than, how far right does it go?
2.
That's at the x value of 2. Any equal to's?
Both.
Both of them. They're both filled in circles, so they're both equal to. Okay. Got it? That's just for what we're doing. You just have to be careful. The only unfortunate part, especially since this is a Savas assignment, there's lots of little places to make mistakes, aren't there? Okay, so that's where you'll have to be careful. And what I will say is that before you start to get frustrated, come see me, okay? Because if you put something in and you get it wrong, there's a chance it's just one little small box is wrong. But unfortunately, they have you put this in all at once, if I recall. Okay, so if you start to get frustrated, come see me and let me look for your mistake and say, oh, hey, it's that number right there that's wrong. And then you can try and figure out what you did, as opposed to, you know, getting really frustrated with it. Okay, so that's the way, you know, I mean, I'm always willing to help, but that's a good way that I can help here. So, okay. Let's practice with this next one. How many pieces are you thinking here?
3.
Still 3?
Yeah.
Yeah, because even though it's only showing as 2 parts, it's still 3 because that 1 is 2 different pieces, isn't it? I don't have an equation that for something that turns like that. I have to do it as piecewise. Okay, I'm going to start my left, so I'm going to start with my horizontal piece. And there is a warning to beware here that we'll have to talk about here in a moment. Okay? What do we think here for this equation? See, I don't want to call on you too. That's a good thing, because that means you've been giving me what I need. You've been giving me answers. You've been talking to me. So it's not a bad thing. That's a good thing that I don't want to talk to you. See, I'll take Jack this time, but he'll get ruled out too. So 7. Plain old 7, right? Horizontal line. So it's just a plain old 7. Now, are you guys agreeing with this 7, I hope?
Yes.
What do you have to watch out for here?
Where you,
We're counting by 2s, aren't we? They do that in homework some. Okay, I had a complaint first hour that one of the problems they were counting by 2s on one axis and 4s on the other axis. So you have to be very careful. And you'll see as we go through this one why. Okay, so this is 7. It's just that horizontal line. On what domain? How far left does that green line go?
-5.
Okay, it's in between there, right? The line would be -6, so -5 less than x less than, how far does it go on the other way? -2. Any equal to's?
Both.
Both are equal to. Good. Okay, whoops. Next piece. Okay, I need a y-intercept and I need a slope. Caleb?
5 minus 6.
Okay. Can we agree with the y-intercept of 5?
Yeah.
That definitely looks like a 5. Yes, that's a positive 5. Now, the slope, what'd you say? Minus x, so a -1.
Yeah.
What do you think, guys? We can think of this a couple different ways. If I count down, say, 1, 2 to that 5 line, and then over 1, 2, down 2, over 2, right? Or you could count down all the way to this line if you want, and go down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5. It's however you want to do it. But this is a down 1 over 1 scenario. So it is a -1 slope. I'm going to write mine as -x plus 5. Caleb said 5 minus x, didn't he?
Yeah.
That's equivalent. That's perfectly fine. And I think Savas will even go for it too. Okay. On what domain? How far left is this graph going?
-2.
Less than x, less than. That goes over to 3. Any equal to's? Both of them again. Okay, I feel like you guys are catching on to domain. That's good. Okay, one last piece. Okay, we need a slope and an intercept. I tend to start with slope on this since I can't see where it crosses. Okay, gotta get slope in my head before I can ask you guys. What are you thinking, Jack?
2x plus 1
2x what?
plus 1.
Okay, I don't know about the +1 yet because I haven't thought that far ahead, but I'll definitely agree with the 2. The slope is 2, yes? And if we look here, you can count up 1, 2, 3, 4, and then over 1, 2. So rise 4, run 2, 4 over 2 is a 2 slope. Yeah, I didn't think I agreed with 1. So if you're not sure, count down, right? And it's hard to do here, but if I count down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1.
Over 3.
That's what I would say.
I'm over a half, maybe 3.
Oh, okay. That's the best suggestion I can do. Now, in all honesty, if you have the paper here, this should be pretty precise. Could you grab a ruler and line it up and go for that and hope it's right? You could. That's not going to work on the computer screen, though, is it? So, okay. What is my range on that? How far left and how far right?
4.
4, less than x, less than
6.
6. Any equal tos?
Second one.
At 6. Okay. They're doable, guys. It's all little stuff you know. Just be careful on Savas. Take your time and let me help you when you get frustrated if you get a piece wrong. Okay? Okay. What?
That's on the front. That example is on the front of the paper.
Is it really?
Notes, yeah.
I didn't remember that. So, okay, well. Oh, it's the example up there, isn't it?
Yeah.
Okay. I hadn't realized that. I didn't remember that, I guess. Maybe I realized it at the time. Who knows? It's still a good example, yes.
Yes.
How about a word problem for you? I know how we love our word problems.
Something like that.
Okay, so piecewise function means different things happen at different points, okay? It's not just all one equation that we can write. So a phone company offers a monthly cellular phone plan for $25. The plan includes 250 anytime minutes and charges 20 cents per minute above 250 minutes. Write a piecewise defined function for C of x, the cost of using x minutes in a month. Okay, so what I know, write a piecewise defined function for C of x. Instead of f of x out front, I'm going to say C of x equals. And I'm going to have my little squiggly brace there. Okay. We need pieces here. What's something you know that's happening? What do we know at the start of this phone plan?
You get 250 minutes.
Okay. So, first option is that your phone plan cost you $25, just a flat $25, right? And during that time frame, you get up to 250 minutes. So one of my pieces here is going to be just C of x equals 25, because we're writing an equation for the cost. So at some points, the cost is 25, flat out 25. On what domain? When is my cost 25?
Yeah.
0 to when?
250.
250 minutes, right? Anywhere from 0 minutes to 250 minutes. So I'm going to write this like I was other places. 0, less than x, less than or equal to 250. Now, with that in mind, equal to's or not. Let's talk about the 250. That's the obvious one. Is 250 included or not included?
Yes.
This plan includes 250 anytime minutes. So that is a less than or equal to. Now, I would argue 0 could really be looked at either way here. Okay? Because, I mean, if you have the phone plan, even if you don't use any minutes, you're still paying for the phone plan, aren't you? Okay? But some people would argue, well, if I don't use any minutes, then I don't have to pay anything. But I don't think that's really how it's set up. Here's what I learned the hard way helping someone this morning, is that there's one in homework that's a word problem, and they did include 0. So I think my suggestion is going to maybe be think about including 0, because I'm trying to give you a hint about homework that they include 0. Okay? I know at that time we were using interval notation instead, because there's a parenthesis versus bracket mistake. Okay? But same idea. Okay, my plan is either $25 or what's the other option for my plan?
20 cents more for each run over.
Okay, 20 cents more for each minute over. How do I express that as an equation? What do you think, Savannah?
0.2x plus 25.
Okay. We still have that $25 cost, yes? That hasn't changed. And I'm actually going to write it the other way than Savannah said it, but it doesn't matter. So it's going to be the $25 cost plus 20 cents per minute. How many minutes? Just x. So I'm going to say 0.20x. Or you can just say 0.2x. Now, Savannah had said 0.2x plus 25. That's equivalent, right? On what domain?
250 to infinity.
Okay, 250 to infinity. Fair enough. I'm going to just say as in x greater than 250. Okay. That's a word problem for you. You'll see something like this in homework. Look for the pieces, try and put it into an equation.
That's all.
That's all. That's all we have to do for that one. We're just writing the equation. Okay, the bottom one is another piecewise function. Officially, I'm going to call it a step function, and you'll understand once we graph it why I'm calling it a step function. Okay, but it's just a specific type of piecewise function. So this table represents fees for a parking lot. Graph the function, and then we'll talk about domain and range. So we've got time intervals here. Every 3 hours, 0 to 3, 3 to 6, 6 to 9, 9 to 12. And we have costs for each of those time intervals. $10, $15, $20, and $25. So think about, let's just one piece at a time here. So how am I going to graph the fact that my cost is $10 if I'm parked in that garage anywhere from 0 to 3 hours? How are we going to graph that? What do you think, Logan?
Start at 10 and go over 3. Says the 3 hours.
Okay, so I assume you mean starting here at 0, 10,
Yep, and go over the
and then we're going to go over to 3. Does that make sense? That's showing me at 0 hours, my cost is $10. At 1 hour, my cost is $10. At 2 hours. At 3 hours, my cost is $10, isn't it? Now, I need some endpoints. I didn't put those on yet. What kind of endpoints are we going to have? Yeah. The first dot is going to be an open, non-filled in dot. The second dot is going to be a closed dot. Okay, next piece. If I'm parked anywhere from 3 to 6 hours, I'm going to be paying $15 to park. Okay, so at 3 hours, 1 minute, I am paying $15 instead of 10. How annoying, right? Okay, Savannah?
You would go over 3 up to 15.
Okay. At 3, we're going to go up to 15, and then we're going to be up at 15
Until 6.
all the way to 6. What about the endpoints?
1 open, 1 closed.
Open and closed. Okay. $20. At 6 hours, what happens to my price?
Goes up to 25.
Goes up to 20. So at 6 hours, we're at $20, and we're going to be there from 7 to 8 to 9. Looking at those endpoints again. Open and closed. And are you ahead of me? Have you done the last one yet or no?
Yes.
Or are we just barely keeping up? $25. So at 9 hours, my price jumps. So at 9 hours here, I was at 20. That was the end of one interval. But the beginning of the next interval is at 25 here. So from 9, I'm going to go over 10, 11, 12. And again, it's still the not equal to and then equal to. So it's still an open circle and then a filled in circle, yes? Now do you see why it's called a step function? Looks like steps floating in the air, doesn't it? They're just not connected to each other. Okay, 2 things to finish this problem up. Then the time is yours. Domain and range. Thoughts on domain? How far left?
0.
How far right? What are you thinking, Jack?
12.
What do you mean 12?
Huh?
Oh, never mind. Okay, so 0 to 12. Do we end up using every single number along the way?
Yes.
Yeah. 0 to 3, we're right here. What happens at 3? It jumps up and keeps going, doesn't it? 3 to 6, 6 to 9, 9 to 12. Goes the whole way. Now, let's see. I have interval notation on this one. So 0 to 12, parentheses or brackets. On 0, we're going to use parenthesis. On 12, I'm going to use a bracket. Okay. Range. The question is, how low and how high do we go, right? It's a weird one, isn't it? What do you think, Savannah?
Would it be from 10 to 25? Or would each individual number have to be in its own?
I'll talk about notation here in a moment, but we're going to list just specific numbers. Because here's the deal. The first value I could pay is $10, yes? Do I ever pay $11, $12, $13, $14? No. I pay $10, or I pay $15, or $20, or $25. Now, in a range situation like this, think about how you've listed range for years. When you're just listing a set of numbers, I'm going to use the squiggly brace, 10, comma 15, comma 20, comma 25, and the squiggly brace is there. Okay, so when you're just doing a list of numbers, the squiggly braces that we all struggle to draw at times, right? Put a squiggle. I don't care. It doesn't have to be great. And then you're just listing those numbers that are included in the range. Okay. That's it. You got about 15 minutes of work time to use. Okay, so use it wisely. If 1.2 quadratics didn't get done, make sure you get that submitted as soon as possible. And then 1.3 is available and in there.